Complex numbers. Complex numbers are written in the form a plus bi, where a and b are real numbers. A is a real part and b is an imaginary part of the complex number. So anytime that someone tells you that you have two complex numbers that are equal, this will only be true if the real parts match and the imaginary parts match. So the a without the I would have to match the c, and the b with the I would have to match the d. Find the imaginary part and the real part of the complex number. So the imaginary part is always attached to the I, the imaginary part is -5, and the real part is +6. Here, what's attached to the I is 0.2, the imaginary part is 2, and the real part is 3/4. Now this looks a little more complicated. Again, it's supposed to be written in the form of a plus bi, so we could rewrite that as 1 minus 1/4 I. So the imaginary part is -1/4, and the real part is 1. The imaginary part, this is all attached to the I, is 0.8, and the real part is 0. We didn't see a number there, and the only number that we can add and not change this expression is 0. The imaginary part here is the square root of 2 over 2, and the real part is -5. The imaginary part needs to be attached to the I. As you see, there's no I in this problem, but I could add no I by putting in +0i. So the imaginary part is 0, and the real part is 121.